All right, how's everybody doing out there in Math Magic Land? This is Mr. Muscarella coming at you. And in this video, we're going to take a look at sketching positive angles that are measured in radians. How do you know an angle's in radians? Because you'll see this thing like a piece of pie stuck with it. So 3 pi over 4, or maybe 7 pi over 8. And who doesn't like pi? I don't know, that's just crazy. But anyway, you are going to see pi in your angle. Not like this, 30 degrees, because that's in degrees, not radians. So see a piece of pie? You know you're in radians. Now, one of the things that's going to be really important are these things called quadrantal angles. Now let's kind of think about this thing right here, this little circle. So we've got a unit circle, right? Now circles, if we started at the center and we extended a segment or a ray outside of it, that ray would be called the radius, all right? So the radius, is going to be a segment that goes from the center of the circle to the edge. Now in a unit circle, what's really cool is that radius is always going to be 1. Always going to be 1. Now, in regular graphing, all the graphing we've done before, you had this XY coordinate plane, and your X was here, and your Y was here, and this would be quadrant 1 in this spot. Over here, you'd have quadrant 2, then quadrant 3, and then quadrant 4. And that's how the Cartesian coordinate plane was laid out, so we could map stuff out in a way that made sense to us if we were to take a look at it in a grid space. Now, when the unit circle got together with this, we've got things a little bit differently. So we're going to take a look at these things called quadrantal angles. Now the quadrantal angles are going to be in the north, south, west, and east piece of our unit circle. Now again, if we started at the origin, right here, and we extended everything out, that radius out, we would have a radius of 1. And the quadrantal angles are going to be pi over 2 pi, 3 pi over 2, and 0 and 2 pi. They're both going to be in the same spot. Now when you draw this circle, you're going to start on this piece right here for positive angles, and you're always going to move in a counterclockwise direction. So if you make 1 revolution, your circle just like that would look just like that. But sometimes we might make more than 1 revolution. So wherever we start, we're going to go around and keep going and going until we end up stopping at some point. Now wherever we stop, that's going to be called the terminal side of an angle. So the angle is going to have 2 pieces to it. So if you remember from your geometry days, a ray, if you had 1 ray that extended in this direction, say another ray that extended in that direction, where they met would be called the vertex, and you would have an angle that would be formed in between these 2 rays. And it's the same thing for the unit circle. The only difference is you're going to have to put a little arrow to indicate what direction you opened up those 2 rays. And for positive angles, they're always going to open in a counterclockwise direction. So even though you might have an angle that looks like this, but you might start here and then go all the way around. So it's going to kind of look like Pac-Man, but you have to make sure that you put an arrow to indicate which direction you're moving. Now the other thing that you're going to need is you're going to need to make sure that you have the 2 rays. So 1 ray is going to be right here, and that's always, that ray that's right there, that'll always be your starting point. So that's called the initial side of your ray. And then wherever you stop, so say you end up going right here and you stop, so that's going to be called the terminal side. So and you'll put arrows on both of those, and you put another arrow that indicates a direction that the angle opened up in. So you'll need those couple of things. And then sometimes some people will want you to put the angle measurement right here, like going back to degrees. Say, oh, that was 130 degrees, then we would label it 130 degrees. All right, so let's go ahead and take a look at our first example here that's in radians. Now with radians, what I always like to do is take a look at this denominator. In this case, I have a denominator of 6. So what I'm going to do is go to where pi is, or 180 degrees, and I'm going to put 6 in front of it and underneath it. Because now if you think about that, 6 pi over 6, if I reduce that, that of course would just be pi, because the 6's would cancel out. The 6's would cancel out and be gone, and you would just have pi. But the same idea is going to hold true for 2 pi. If I looked over at 2 pi, I would just multiply that by the denominator, 5 pi over 6. I'd multiply it by the denominator of that, which is 6. So 2 pi changes into 12 pi over 6, because again, if I reduce that, now I'll get down to 2 pi. So 2 pi is going to be 12 pi over 6. So this is the first step, is to get all of our quadrantal angles measured and rewritten so that they have the same denominator as the angle I'm trying to draw. What I'm going to do is look here at 0 and then 6. what's halfway between 0 and 6? So if I go from 0 to 6, the number that's halfway in between those two, of course, is 3. So in the top here, where pi over 2 is, that's going to be rewritten as 3 pi over 6. And again, if I reduce that, then I'll be right back down here to my pi over 2. Now that top angle, the pi over 2, the 3 pi over 6, I can add 3 pi over 6 to 6 pi over 6. And if I add that together, 3 pi over 6 plus 6 pi over 6, that would give me 9 pi over 6. Now, of course, if I reduce that, 9 pi over 6, I would end up with just 3 pi over 2. So the 3 pi over 2 angle, or 270 degrees, that's going to be rewritten as 9 pi's over 6. Once I have all 4 quadrantal angles rewritten, then I'm going to go ahead and sketch my angle. 5 pi over 6 is my angle, so what I'm going to do is count. So from my x-axis right here, I'm going to go ahead and draw to this spot. Now that's only 3 pi over 6, and I need to go 5. So if I continue that on and go all the way to here, well, that's 6 pi over 6, and that's too far. I don't want to go quite that far. So I'm going to go a little bit less than that. So I'm going to go a little bit less than that, and that's going to be where 5 pi over 6 is going to end up. So what I'm going to do is go ahead and draw that terminal side, and then don't forget, make sure you have the initial side. So I'm going to sketch that part too, and then put arrows on both of those, because that's my vertex is going to be right here at the origin. And then I'll label my angle 5 pi over 6, all right, because that's the angle I drew. Now the last thing I need to make sure I do is put the arrow to indicate the direction, that your angle opened up. All right, so that's 5 pi over 6. So that'd be a rough sketch. It doesn't have to be exact, because that's all you're asked to do is just sketch the following angles. All right, so here's 5 pi over 6. Now the next one we're going to do is going to be 15 pi over 4. All right, so that means pi is going to become 4 pi over 4, because again, my denominator is 4, so pi is the one I go after first, so that's going to be 4 pi over 4. Now if I double that, that would be 8 pi over 4. So 2 pi is going to be the same thing as 8 pi over 4. Now, halfway between 0 and 4 pi is just 2 pi. So pi over 2 is going to be rewritten as 2 pi over 4. Again, everything's got the same denominator as the angle I'm trying to draw, 15 pi over 4. Now I'll take 2 pi over 4 and add that to 4 pi over 4. So 2 pi over 4 plus 4 pi over 4. So 2 pi over 4 plus 4 pi over 4 is 6 pi over 4, which is going to be reduced down to 3 pi over 2. So my last quadrantal angle, 3 pi over 2, is going to be renamed or reorganized to be 6 pi over 4. Now, I've got all 4 quadrantal angles all set. So now I just count by 2 pi's over 4 until I get to 15. So here I go. I'm going to start right here at this spot. I'm going to start here and then go 2 pi, 4 pi, 6 pi, 8 pi. Keep going. 10 pi, 12 pi, 14 pi. Now if I go another 2 pi, I went too far. So I'm going to go halfway in between, and then that will be where my terminal side ends up. So again, put a little arrow to indicate the direction that I was moving. So make sure we have that. And then I've got the arrow on the end of my terminal side. And then don't forget, make sure you draw that initial side piece right there. All right, so that is what the angle 15 pi over 4 would look like if we sketched it. Now here's this one, 7 pi over 8, 19 pi over 12, and 17 pi over 6. What I want you to do first is go ahead and sketch these out, but go ahead and rename all the quadrantal angles first, because if you get that right, you'll be smooth sailing for the rest of it. But if you make a mistake on that, then your drawing is just going to be off. So I want to make sure we get that right first. So go ahead and hit pause, then come back after you've got that drawn. All right, so there are the quadrantal angles for each one of those, 7 pi over 8, 19 pi over 12, and 17 pi over 6, rewritten so that they have their same denominators, whichever angle we're trying to draw. Now go ahead and hit pause and draw each one of these angles, and let's see how you did with it. All right, rock stars, how'd you do? I'm sure you got each one of these correct, and you made sure to label the angle, put your terminal side in, initial side, put arrows on those, and make sure you put an arrow to indicate the direction that you are opening up here. Now, this last one, 17 pi over 6, sometimes people will have you, make sure that you go through and write the, measurement of the angle that you just drew. All right, so that way if somebody's looking at your work, they know, yep, that's what you meant when you drew that angle. All right, so that's it for this video. That's just a quick introduction to sketching angles that are measured in radians. All right, so by now you should be able to have a pretty good grasp on that, and I'm sure you'll have plenty to practice in class by your teacher. All right, thanks for watching today, boys and girls. You have a great afternoon, evening, or good night, but I'll catch up with you soon. Peace out.